Everybody, I am so excited to be here at Live 360. Finally! I was scheduled to speak at Live 360 twice before. And I had to cancel because of this little thing, a little run-in I had with cancer. But that is all over, and I am now back on the speaking circuit at Live 360. And that makes me so incredibly happy. Thank you all. So before we begin, I figured we'd do a quick introduction. There we go, that's better. So my name is Abel Wang. I'm a developer. I write code. I sling code all the freaking time. And the running joke that I always tell is I do it so much, it makes me happy, right? I am that weird dude at Microsoft that writes code so much that I'm super exhausted by the time I get home. So I play with my dog, make dinner with my wife, and then when we sit down to watch TV, I'll pull out my laptop and start writing more code because that's what I love to do, right? Today, we are super lucky because joining with me is going to be the amazing Jessica Dean, right? Jessica is all about ops, and that's where she comes from. And the cool thing is, we actually are on a bigger team called the League of Extraordinary Cloud DevOps Advocates, which may be the most ridiculous name ever. However, what we do is not ridiculous, right? What you're looking at right there is 5 DevOps practitioners that really span dev, which is me, pure dev, all the way to pure ops, which is Jessica. And our sole charter is to come out here and help all of you get into Azure using DevOps best practices. Now notice I didn't say get into Azure using Microsoft tooling, because literally we don't care. You want to use Jenkins, you want to use Spinnaker, you want to use whatever, you can use whatever tools you want to get into Azure. We will help you get into Azure using DevOps best practices. Now, we're a great resource. We're here to help everybody do that. If you have questions, feel free to reach us, ping us, ask us. How do you get a hold of us? Do not email me, because I may or may not read my email ever. Well, maybe like every couple of months. Easiest way to get a hold of us is on Twitter. We are all on Twitter way too much. It might be an American thing, I don't know. But that's where we are. And if you hashtag it LOECDA, that will literally light up a team room for us. We'll see it, we will answer your questions if we can, and if we can't, I will find the person at Microsoft that can. So we are a resource. Please, please, please use us. All right, so today we're going to be talking about DevOps in real-world DevOps, not this fantasy world of DevOps that most of us talk about in conferences. But what exactly is DevOps, right? I asked 10 people, I'm probably going to get 20 different answers. So what is DevOps? To us at Microsoft, DevOps is something very, very specific. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. And I said this very, very carefully because every word has meaning. Notice I didn't say continuously deliver code, right? Because what will that give us? Piles and piles of code sitting on some server somewhere. That does us no good whatsoever. And notice I didn't even say continuously deliver features, because I can be delivering feature after feature, sprint after sprint. And again, if this is not what our end users need, why am I wasting the time doing this, right? We need to continuously deliver value. That right there is the key. And why is it so important to continuously deliver value? Well, the speed of business today is so ridiculously fast. It is so insanely fast that the only way, as an organization, as developers, the only way we can keep up and iterate fast enough and innovate fast enough is if we adopt DevOps best practices. If we don't, we just won't be able to keep up. All right? So here's the key. If you don't adopt DevOps best practices, your competitors, they either have or they will. And once they do, they will out-innovate you. And when that happens, what happens to us? We become obsolete. And none of us wants to be obsolete. Now, I've been talking about DevOps for quite a few years now, about 7 years. And I've been saying the same type of stuff for about 7 years. But I didn't know if it was true. I mean, I thought it was true, and I felt it in my gut it was true, but I didn't know for sure, right? But now we've been DevOpsing long enough that we know 100%, absolutely this is true. Teams that adopt DevOps best practices totally out-innovate teams that don't. It's not even close. So that's why it's so ridiculously important. Adopt DevOps best practices or die. All right. It is not easy to do right, though. In order to do DevOps right, you really have to address all three of these pillars: the people, the process, and the products involved. The people, that's a cultural shift, a cultural change that has to occur within your organization. All right. I could spend an hour talking about the cultural change that needs to happen. This is the most difficult and the most important part that has to occur within your organization. This is not what this talk is about, so I'll just say that when it comes to culture, it needs to start from the top and work its way all to the bottom. And every single person must be hyper-focused on continuously delivering value to the end users. Continuously and hyper-focused, right? This is incredibly important. What type of process do you need? That's the easy part. Anything agile, guess what? That works really well. And I'm not going to say that agile is the only process that you can use, but you do need a process that will let you iterate fast enough, yet still deliver code of high enough quality, right? And then, of course, you need to have products, tools, that can help enable all of this. So your tooling needs to do a lot, right? Your tooling, it needs to be able to track the work that you do from one iteration to the next. So you need to have things like backlogs and Kanban boards and visual tools that will help you manage all of your work. And for your developers, they need to have tooling as well. They need to have their IDEs, they need to have source control systems, they need to be able to check their code in and associate the changes that they did with the work that they're doing. And as soon as code hits the source code repository, it should kick off automation. Builds should kick off. Unit tests should be run. And if everything looks good, then automated bits should pick up those bits that we just built and deploy it in my dev, QA, UAT, all the way out even into production. And it needs to be automated. Why? Because this could happen a lot throughout the day, right? And if that's the case, human beings make mistakes. So I want it automated because I need this to be consistent every single time. And I need this to be reliable every single time and repeatable every single time. So I always tell the story of a very young developer at Microsoft who was working on a project, checked the code in, started testing. He forgot to change the connection string in the web.config file, so it was still pointing to production data. So while he was testing, man, he was wrecking production data. Right? Luckily, this young dev was not fired because it was me. However, as bad as that sounds, that's something that typically happens to us all at some point in time, right? Maybe not to that extent, but if we have to do something over and over again in a manual type of process, we're going to tend to make mistakes as human beings. So if our pipelines are automated, great, consistent every single time, repeatable every single time, and you get to test out your process when you go from one environment to the next to the next. So by the time you go into prod, you're fairly certain that things are going to work the way that they're supposed to. And once code hits production, though, it doesn't end with code hitting production. Because once code hits production, I need to be able to monitor my application as well. I need to be able to know, is my app up or down? Is my app performing well? And what are users really doing in my application? Because if you can tell me those things, then I can know, am I delivering value? And if I am, hooray for that. For the next iteration, we can double down and keep on doing stuff that our end users need and want. And if I'm not, it's not a big deal either, because I can immediately course correct and then try something else. And hopefully we can land on something that our end users find valuable. And lucky for us, there are all sorts of toolings out there available for us that does all these different things, right? Right about now, this is when I start putting on my Microsoft hat. And I said all of these tools, they can ultimately be replaced by services that are built directly in Azure, called Azure DevOps Services. Right? What is Azure DevOps Services? It is literally everything you need to take an idea and turn that idea into a working piece of software in the hands of your end users for any language, targeting any platform. So it's pretty cool, right? And right about now is when I usually show a really fancy demo. And it's flashy, and it's rainbows and unicorns, and it's beautiful, right? I make some changes to the website, I check it in, and bam, it shows up, goes through a pipeline. Got to show the moving bits, right? And then all of a sudden, in production, you can see my changes have occurred. Yay, I'm awesome. However, that's not very real world-like. The real world, especially in the world of DevOps, looks way more like that. So what I figured we would do, me and Jessica, is we are going to show you DevOps using a real-world application. And the application we're going to use is called Rock, Paper, Scissors, Lizard, Spock. And if you guys don't watch Big Bang, I don't know what you're doing in this conference then, because I think we all do, right? So this one, it's actually a very complex application that uses microservice-based architecture. There are 7, I think, microservices running in 7 different languages, and they're all running in containers inside of a Kubernetes cluster, right? There's going to be a database as well. There's going to be an iOS application as well. So there's a lot of moving pieces here, and because of that, it presents us with some real-world problems as well. The first problem that I have with this is, remember, I'm a dev, right? I write code all the freaking time. And in fact, I've been writing code for over 20 years. That's how freaking old I am. Do you know what I think about writing code for Kubernetes? I can do it, but it's a pain, especially that inner dev loop. Hopefully, there's a way we can make that easier, right? The next thing is our application, it's not ready for real microservice deployments. I mean, I know it is designed as microservices, but it doesn't work very well when we try to deploy it, right? The biggest key of microservices is you get to deploy only the microservice that changed, right? Great. So then our deployments are much smaller, easier to test, et cetera, et cetera. So I tried this out, built out my pipeline, and it worked maybe 2 times. And then I started running into versioning problems and dependency problems, right? So if service A depends on service B, the order that you deploy starts to matter, or you're going to get downtime. And if service A depends on service B, that depends on service C, that depends on service A, oh crap. Now what do you do? Right. So I thought about this, and I came up with a brilliant idea, except it's really not my idea. It's something that we use inside of Azure DevOps. I need to make my services smart. I need to make them smart enough so they can talk to each other. And I can say, hey, you, service A, what version are you at? And you can tell me, service B, I'm at version 27. And I'll be like, oh man, I wish you were on I wish you were on version 30, but since you're on 27, let me turn off all my feature flags, turn on 27 feature flags, now I can communicate with you. And now I won't break, and now I can function perfectly. And best of all, I've now removed that dependency between the services, so now, guess what? I can deploy in any order and things become much easier. Problem solved, yay, I'm brilliant. However, and there's always a however, I can't do it immediately because that's more code that I have to write. So what do I do about it right now? The answer, unfortunately, is I kind of have to treat everything like a monolith right now until I can make my app smart enough to do that, right? But trying to deploy everything, 8, 7 microservices, databases, and all that stuff, that seems kind of daunting. Not sure how we're going to do that, right? The other thing is trying to spin up all of this infrastructure and everything is hosted in Azure. Oh my goodness, that's a serious pain. Like trying to set up my Kubernetes cluster, trying to set up my SQL Server database, my Cosmos DB, setting up some storage. Serious pain to do this. I don't want to have to do this by hand every single time that I need to. Right? The other problem that we have is the microservice architecture. Very, very difficult to join together on the back end because ultimately they all end up with different domain names, which means some of these microservices start getting CORS problems, right? Which can be solved. But again, that's more code that I have to write. I sure wish there was a way I can solve it really, really quickly without writing more code. Finally, there's a couple things, right? We've got databases, so we have to think about how do we do database DevOps. We have a mobile piece, which means we have to worry about mobile DevOps. Then we have to maintain quality. How do you maintain quality in a DevOps world? How do you maintain security in a DevOps world? And finally, what about things like setting up DNS and setting up my search for HTTPS? Because my ultimate goal is I want to be able to do complete 100% disaster recovery. So if somebody even deletes absolutely everything from my Azure subscription, I don't want to have to spin everything up. I just want to press a button and everything just magically just gets fixed. Right? So hopefully we have solutions to fix all of this. For the Kubernetes issue, we need Azure DevSpaces. And we'll walk you through a lot of that, right, to show you the goodness of Azure DevSpaces and how it makes developing in your inner loop for Kubernetes so much easier. And for the rest, what we need is DevOps Nirvana. We need to have a magic pipeline that will take care of everything for us. So what I want to do right now is kind of walking through our demos. And the first thing that happened is rock, paper, scissors, lizard, Spock. It has a bug, so we need to fix it. We need to do this inner dev loop, which is such a pain. And I wish I had a developer that could come on stage and show me all of this. Do we have a developer in the house? Yes.
Well, wait, hold on, Abel. We actually have a problem, because Abel introduced me, and my background's more ops.
You're totally ops.
But we work on a DevOps team, so luckily we kind of share a lot of responsibilities and we communicate. So I brought a friend. I actually brought your long-lost cousin.
Oh, you did?
Yes, so hold on one moment. I unfortunately made him hide. All right. Hi, I'm Fable. I'm ready. All right, I am fake Abel. I have my developer hat. Oh, wait, also Abel always wears rings, so we're going to wear some rings.
That's right.
All right, they're my magic rings, so they make sure that I can code. So as Abel talked about, obviously not Fable, as we talked about, there's a problem in the application. Now, I want to show you, let's switch over to my computer here. I want to show you the actual application, rock, paper, scissors, lizard, Spock. I'm going to go ahead and sign in here. I'm going to use, I guess I should type in Fable, so you can see that. And there's a few other things I want to show you here. Let's pay attention also to this DNS name right here, devmain.rockpaperscissorslizardspock.dev. That's going to become important when it comes down to the actual dev spaces part of it. But I want to show you the expectation of the game. So there's a whole bunch of rock, paper, scissors. Everyone knows that, right? Paper covers rock, rock crushes scissors, all those things. It gets a little bit more complicated when you throw lizard and Spock into it. Fun fact, paper actually beats Spock because paper disproves Spock. And if you're wondering how that works, it's because Spock is a scientist, and paper, someone can write a paper about disproving the scientist's lifelong work, and therefore paper disproves Spock. So there's all this stuff of like what wins, what loses. Let's go ahead and choose .NET. We're at Live 360. Choose Select. I'm going to go ahead and choose Spock just because I like science. And I'll choose Start Battle. And on the right-hand side, you'll notice the bot. Every language is a bot. It looks like I won. Yay. But it looks every language is a bot, and at the end of it, you're supposed to see a picture of what's actually produced, right? We see rock right here. If I choose the opponent, I can go over into Python. I can choose Select. I'll choose Lizard this time, because that's also a fun one. I don't really know how to make all the hand gestures sometimes. And now there's a tie, so that's also fun. But we can see very clearly that there's a picture right here that's supposed to pop up. So the bug that Abel was referring to, we just found out, is actually in the node service. So I'm going to choose scissors this time. I'm just going down the list. And I start the battle. And we're going to see pretty clearly right off the bat what the issue is. Oops, I have to update the rocket. It's not properly showing whatever the bot selected. So in the concept of 7 different microservices, how would you debug this, right? If you're a developer, maybe you're trying to sit there trying to figure out, oh, there's all these problems. If you're an ops person, how do you confidently guide your developers to the issue, especially when the only way to really kind of debug it is to see it with the other 6 microservices involved? So I have VS Code open, and I only have the Node Player API bot up on my screen, right? That's the only folder in my source control that I have. I don't have anything relating to Helm charts or Kubernetes manifests. Since I'm fake Abel, much like my cousin, real Abel, I don't really like dealing with containers and Kubernetes and all this nonsense. It's just very challenging. So thanks to dev spaces, I don't have to. In fact, I can deal with all of this completely native and uncontainerized. I'm going to set a breakpoint right here on the return call. This is where I'm returning a choice list for the player selection, for the bot selection. And thanks to something called Azure Dev Spaces, which is just an extension, you can see the Dev Spaces right here. This is the only thing I have installed. You set up Dev Spaces on your Azure Kubernetes cluster. I'm going to be able to do live debugging right now. So I'm going to hit Command-Shift-P on my Mac. That would be Control-Shift-P if you're using a Windows. And you essentially search for Dev Spaces. We're going to choose to redirect an existing Kubernetes service over to this machine. Now, once you do, you're going to be given which service do you want. Now, I want to be very clear. What you're seeing up here is not languages. Those are the bots. Those are the services that we're working with. So I'm going to choose the node service. And from there, I can choose a mode. I can either redirect all traffic over to my machine and replace node, which would also replace it in production. I don't want to do that. So instead, I want to clone. Clone is going to create an isolated copy of that service in a child dev space. Not because I'm a child, but because I want to make sure that I don't break anything. So this is kind of like my own personal sandbox. You can see that there's quite a few. There's other people on the team that are also able to work with this. So I'm going to choose the one with my name on it. And from there, I'm just going to enter the port of the application, which it looks like I hit the wrong button. So we're going to go ahead and do that one more time. So we're going to hit clone again. This is going to be classic node, right? So it's just standard port 3000, nothing fancy here. And I just hit enter. And from there, this is brand new. So Azure DevSpace has been out for a little bit over a year and a half. And now we have something called Azure DevSpaces Connect. This is going to take care of environment variables, telemetry, data, every single thing possible. I do have to, it's running an OSA script, so I'm just going to use my little finger there. The one thing that the Mac touch bar is good for. The one thing, and the emojis. But right after it wires everything up, it sends all the information over to my cluster, it deals with all the Helm charts. Now I'm connected to that dev space. In fact, if I zoom out here real quick, you can see I get a little notification right down here that I'm connected to that sandbox on port 3000. So now I can go over to my debugger, and again, I don't like messing with anything, code, Kubernetes, any of that. I just want to dev. I'm just going to start my debugger just as I normally would, and that's going to connect just as I would normally expect. I can see that it's green. I have a debug console that's over here. I can, again, we talked about this dev spaces icon right here that confirms I'm connected. I can click it, and it actually brings up an option to where I can go to the web. Now remember, right when I first started talking about the application, I was talking about the primary domain. I told all of you to pay attention to it. This is why. This dev space that it just created is a subdomain that now I have access to as a developer. So I can now do live debugging in an uncontainerized, very native way, working off of just a subdomain without touching production at all. So this is already simplifying my inner loop tremendously. And if we also remember, we set that breakpoint, right? So that's going to come in handy. So I'm going to do Fable again. I'm going to go through, and we're going to recreate the problem so I can hit that breakpoint and figure out what the issue is. I'm going to do everything just as I did with scissors, and right off the bat, I already hit the breakpoint. This isn't smoke and mirrors, this is very real. We'll zoom in here, and I'll zoom in a little bit further. Now, I have IntelliSense that actually when I hover over the RPS choice list, I can see my problem right off the bat. Fable doesn't know how to spell. I left out the letter E in paper, right? I would like to blame the Mac, but unfortunately my Mac only has issues with the B, C, and V key, so I can't really blame it for the E. I'm going to do what every good developer does, though, and I'm going to use find and replace. So I'm simply going to search for paper. I find paper in my RP SLS options list. I'm going to add in the E. I'm going to save that, as long as that's saved. And then I'm going to go ahead and restart. Then we're going to go back over. I'm going to, rather than running through and signing in again, we're just going to do Challenger. That's all I added just at the end of that. We're going to choose the opponent. And assuming that that fixed it, we should be, I have to remove that breakpoint. We'll remove it and continue through. Now we should see the application properly show the right icon, which it does. So now, just like that, I was able to fix. I didn't have to deal with Helm charts or pushing or pipelines or any of that. I was just able to do what I do as a developer. So I have confidence that I fixed it, but what about the rest of my team? What about real Abel? What about the other members? We have other people that are all participating in this large application. In fact, it's public. Even you could go and fork the repo and set it up and play with it. So I'm going to go ahead and check this in now. I'm going to say that I fixed the spelling. So we're going to say fixed spelling. I'm going to commit, and I'm going to push. Now, I also have my repo right up here, so I'm going to hit refresh here. And as soon as I push that, you should see that I pushed it less than 1 minute ago. I'm going to hit compare pull request, and we're going to assume that I did all these fancy things. I documented my work. I did all the acceptance that everyone does, and I'm going to create a pull request. Now, we still need, as Abel talked about, to wire up all the other real-world DevOps and get it out and DNS and TLS certificates and all this stuff. But what I really want to focus on is how I can make sure that real Abel, all of you, other members of the team, all have the same level of confidence that I have in my code, and hopefully no one realizes that I didn't know how to spell. So the second I check it in and open a pull request, you'll notice it started what's called a PR workflow. That's because I also have GitHub Actions that's set up on this particular repository and within this particular, anytime I try to merge over into branch. So if I go to details, I can see a running action of everything it's doing. This takes a few minutes to complete, so I want to show you what a completed one looks like. I want to show you how everything that we did with Azure Dev Spaces and Connect is also happening now as part of a pipeline. So you can see that the beautiful thing about GitHub Actions is they're all public, right? You can sit there and you can manipulate it, you can fork it, you can change it. It's very open source and a lot easier to manipulate actions than other CI/CD tasks. So you can see that I have the Azure K8s action that's going to set my context. It's going to create the child namespace and dev space labels. In fact, it's creating all of this in a PR-specific namespace. It's installing that Helm chart, the same Helm chart I would use in production. It's installing it over to the PR. And one of the most important things it's doing is this task right here. It's adding a review URL. So that means that thanks to Azure DevOps and GitHub Actions, you can do this with pipelines as well, by the way. You can do this with any CI/CD tool because it's just code. It actually gets to now participate in the conversation. So if we go over, you can see this was an existing one, obviously. This was where I'm showing you an existing PR. So this was 15 days ago where we made another change to the API. The GitHub Actions bot, as part of that pipeline, actually added a comment with a private version URL. So now we can click that, and everyone else on the team gets the same level of confidence. That means the developers, the ops, even those whose roles traditionally have been unable to participate in the review process. I'm talking PMs, designers, those who don't write code. Everyone gets confidence, and everyone gets to be included. It's like Oprah. You get confidence, you get confidence, you get confidence. But now, it's great that I have confidence. This looks good. I want to merge it. But after I merge it into master, what happens? Where does it go? And what about the rest of the real-world DevOps, right? We solved one particular problem. We solved how the inner loop within microservices used to be very challenging. And by the way, this is still in preview. This is still beta. There are still a few bugs, but this is something that's very revolutionary for that one particular part. But what about everything else? So to help me with getting it out into everything else, into staging, dev, production, canary, blue, green, all of that, I now want to bring an ops person on stage. Do we have an ops person? Fable needs some help.
I'll help you, Jessica.
Thank you so much.
I'm sorry, fake Abel.
Yeah, I'm calling myself Fable.
You know, I brought in some help too.
You did?
I did. I brought in your cousin to help us out as well.
My cousin too?
Your cousin, the ops genius. Hold on a second. Let me go find your cousin.
By the way, the fact that we've had to hide people underneath this table, this is a deceivingly large table. I almost said small, but yeah.
Hi, everyone. I'm fake Jessica. All right, so what we need, thank you so much, Jessica. That's freaking amazing, because I know I'm just an ops person, but what fake Abel tells me is that really makes that inner loop. All right, so the next thing we need to do is she checked the code in. We somehow need to get that out into our production system where everything just magically works, right? So to do that, let me go ahead and dive into my pipeline so we can see exactly what's happening. All right, so here's this is what's interesting. Out in production right now, it's not changing over. That's lovely. Hold on, give me 1 second. Display settings, I'll turn that into duplicate, and that should take care of the problem. Yes. So if you look at my resource group, I have absolutely nothing, right? Because somebody went in there and deleted everything. And granted, it may have been me, but yeah, somebody deleted absolutely everything. So we start with nothing at all, and just by fake Abel checking in his code or her code, everything will just magically get deployed. And the way it does that is through our amazing pipeline that kind of looks like that. Yes, that's a very complex pipeline, but it's also doing a whole heck of a lot of stuff. So I'll kind of walk through everything that I'm doing. First of all, in order to deploy all of the resources that I need and provision everything, I'm going to use infrastructure as code. In fact, you kind of have to use infrastructure as code, because what else are you going to do? Spin every individual thing up by hand every single time you need to do this? That sounds horrible, right? So if I'm going to do infrastructure as code, there's a couple different ways I could do it. I could do it using an ARM template. I can do it using scripts using the Azure CLI, or I can use third-party type solutions like Terraform or things like that. So I thought about using ARM templates. ARM templates are challenging sometimes. How many of you work with ARM templates? Some hands are going up. All right, so the people that raise their hands, how many of you have taken an ARM template, written an ARM template, and bam, it just magically worked? And how many of you love debugging ARM templates? Right. It can be challenging, right? So I wanted to use the Azure CLI because it is so clean and it's so easy. Right? I just script exactly what I need. The only problem with using the Azure CLI as my infrastructure as code is that if I do that, the Azure CLI is sort of idempotent. And by that I mean, if I try to run the same script multiple times, there are some resources that will say, oh, you've already provisioned this, so it's just a no-op and it doesn't do anything. There are some resources, however, that will just flat out fail. And I need these scripts to be idempotent, where I can run it as many times as I want to, but it only does what I need it to do, only does the thing that I haven't done before. So I thought about going back to ARM templates, but the thought of going back to ARM templates, well, I didn't really want to. So then I was like, you know, it's easy enough for me to write a framework around these Azure CLI scripts that will keep track of what version they're at, and then I'll only run the new version code. So the way I got this idea is kind of like Code First Entity Framework, right? You know how they do the database migrations from one version to the next and the next? The way they make their scripts idempotent is they keep track of what version the database is at. So if you're at version 3 and you want to go to version 5, then it's just going to run 4 up and 5 up. Right? If you're on version 5 and want to go down to version 3, then you'd run 4 down and 3 down. Right? So that's how it does things. So I was like, great, I'm going to have scripts that have 1 up, 2 ups, 3 ups. It'll keep track of what version things are at, and if it's not at the latest version, then it'll just run only the ups that it hasn't run before. Right? Idempotency, fixed. So that's what I did, right? So the first thing that I did is I deployed my own set of infrastructure tools. And what is infrastructure tools? Let me zoom in here so people can actually see this. First thing that I do is I decrypt and get all of my secrets from Azure Key Vault. Why Key Vault? Because I freaking love Key Vault. That's why. It's a super easy place for me to store all of my secrets. Microsoft makes me change my passwords, connection strings, things like that. Like it seems like every other week I have to change them. And I use a lot of the same secrets in a lot of my different pipelines. So if I store them locally in the pipeline, that means I have to find every single pipeline that I've made these changes and recycle or change up my passwords in each pipeline. That's a huge pain. If I store it in Key Vault, I can just change it in one place and then magically everybody just gets those changes. Right? So that made my life way, way, way easier by using Key Vault. Plus, it's super simple because as you can see, it's just one simple task. You point it to your Key Vault instance, and that's it. You're done. It turns all of your secrets into environmental variables that you can now reference within your pipelines. Right. The next thing that I do is I provision everything that I need for my infrastructure tools by using a PowerShell script. And this PowerShell script uses the Azure CLI basically to create all the infrastructure that I need. And for my infra tools, what is that? That is a set of tools that I created that will help me deploy the rest of my pipeline. right? So it's internal tools that I first deploy that will help me with my future deployments. And it really consists of a Azure function and Azure storage. So what is this doing? It basically does three things, right? First of all, there is a DNS checker. Why do I need a DNS checker? I'm using Azure Front Door, and Azure Front Door is a little weird because I literally cannot provision and configure it until the DNS that I want to use has propagated all the way down locally, right? So I needed some way to say, hey, did the DNS settings propagate from Cloudflare all the way down to the local machine yet? So I have an Azure function, and that's all it does, is just checks, hey, did DNS propagate all the way down? And if it did, return true, otherwise return false, right? The next thing that I have is the infra version checker, a retriever and updater. So that's what I use to basically say what version is my infrastructure at, and based on that, I will run the ups that I haven't run yet, right? So that's what that does. And finally, there is a mobile environment retriever as well, right? So what is that for? I have a mobile app in this pipeline. The problem with mobile apps, it's really not a problem, but my mobile app has to hit my backend services. And because I hit backend services, that means those URLs will be different if I'm in my dev environment versus like my production environment, right? Because they're backend services. So how do you dynamically change that URL? I had no idea. I was like, it's got to be a configuration file, right? So I looked for a configuration file. I couldn't find it because I'm not a mobile dev, especially since I'm an ops person. So I pinged James Montemagno. So he's my mobile guy, right? I was like, dude, how do you guys do this? And he told me, oh, what we do is we take the URL, we hard code it into our code, and we burn it in there, the URL. So if you have a dev environment and a production environment, we just create two builds. And I kind of wanted to punch him in the face. Because I'm like, really? You're going to create multiple builds for the exact same thing? It's just you're going to different backend services? So I figured there has to be a better way. And so what I'm doing is I'm using an Azure table to hold the build number and also the service that I'm trying to reach and also the URL that I want it to be directed to, right? So now I also have another Azure function where I can just say, all right, if this is my build number, this is my application, and this is a service that I want, what URL is it at? So if it's in the dev environment, it'll return me back to dev URLs. If it's in production, it'll return me back to production URLs. So now I don't have to build my app multiple times. I just get to build my mobile app one time. And now stray code does not magically flow through, right? So as a DevOps person, this makes me really happy. So that's what my infrastructure tools are. Next, in parallel, I am now going to deploy absolutely everything that I need. And it's important that I do everything in parallel because if you've ever deployed a Kubernetes cluster, it takes a while, right? So the first thing that I do is I deploy my Kubernetes cluster. Again, decrypt from Key Vault, and then I run some scripts that do everything. To show you what these scripts look like, this is just an Azure PowerShell script that uses the Azure CLI to do stuff, right? So the first thing we do is we pass in a bunch of parameters. Then I log in using my service principal. And then I have my one up, right? So if it goes from 0, like we've never done it before, to version 1, this is the code that it will run. So now it's going to run some kubectl commands. It's going to run some whatever to stand up my Kubernetes cluster. And it does some configuration and things like that. And at the really end, I need something that will do all my bookkeeping for me, right? I need something that will reach out to my Azure function to say, hey, for this particular infrastructure as code file, what version are we at? And based on the number that you gave me, do we have any higher ups that I need to run? And I didn't want to have massive amount of code that people would just copy and paste all the time. So what I did was I created a PowerShell module. So you just need to copy these 5 lines, copy it and paste it at the end of your script, and everything just magically works, right? So now I can do true infrastructure as code using PowerShell or Bash and the Azure CLI, which makes me really happy because it's so easy to write. All right. So I go ahead and provision my Kubernetes cluster. At the same time, I provision my database. This is kind of neat because when I provision my database, I do some disaster recovery as well. Let me see if I can find this. So here is my provision my database. I pass in parameters, I log in, and then for my one-up, I use the Azure CLI to create my SQL Server database for myself. For version number 2, I decided, you know what would be really cool? Since this only runs if somebody has wiped out my entire resource group and I'm just running this completely from scratch, all of my data is stored in long-term storage. So why don't I go get that, restore my database from the long-term storage, and hooray for that. I actually now have a great disaster recovery tool. So that's what I'm doing in my 2-up. I go into my long-term storage, I download the backpack that I need, and I restore my database. All right? Very, very cool stuff. Next, I go ahead and set up my DNS as well. Right? So DNS, all of my DNS settings is held up in Cloudflare. And Cloudflare has a great set of REST APIs that will let you manipulate and do whatever you want. So that is literally what I do. So we can go ahead and take a look at that. When I provision my DNS, again, same thing. It's just a PowerShell script or a Bash script, pass in parameters, log in using my service principal. And then I'm just calling a bunch of REST APIs from Cloudflare to set up all of the DNS settings that I need to do. Right? So the first time I set it up, I created my 1-up. The second time, I realized I forgot to set my Apex domain. So I was like, oh, well, I guess I need a new version for that. So let me just write a 2-up. So that's what I did. So this sets up my Apex domain. And again, you just copy and paste these last 5 lines of code. And that's all you need to do. Right? So that right there will set up my DNS for me. And remember I said I can't even set up front door until DNS has propagated down locally. So what I've done here is I've created a post-deployment automated gate. Right? So if you're using Azure DevOps services, you have the ability to create automated gates that will use automation to let you decide whether the gate should pass or fail. Right? So using automation, then I can decide whether to go on to the next stage or not. So what this does is, remember I had that function that tells me if my DNS has propagated locally? This literally pings that particular function. And it pings it every 5 minutes to say, hey, did DNS propagate already? If it didn't, you'll wait another 5 minutes. And it will keep on doing this for 24 hours or so. You get to set the timeout. And if it hasn't propagated in 24 hours, I've got bigger problems to go ahead and fail it. Right? So it just keeps on polling until DNS is propagated. And when it finally propagates, then it goes on to the next stage. So the next thing that I do is I go ahead, again, in parallel, I deploy my code into the Kubernetes cluster. So I'm using Helm to deploy all 7 of my microservices. And I also deploy any database schema changes that I have. Right? So I go ahead and do that as well. Some other things that I do is, here we go, this is the right one. So I use the DAC to deploy my schema changes. And when that's finally all done, the next thing that I do is I finally will provision my front door. So when I provision my front door, notice these solid lines, right? So front door is not going to kick off until I've deployed my code into my Kubernetes cluster. And it won't kick off until DNS has propagated all the way down locally. And then it will finally provision everything, right? Because I literally can't until those things have finished being provisioned. So provisioning my front door, I actually do a couple different things as well. I provision front door, which is, again, I use the Azure CLI in a PowerShell script to do all that. But I also configure my HTTPS here as well. So to configure HTTPS, I need to make sure I have a certificate. I need to upload that certificate. I need to do some settings to set my certificate to my particular URL. All of those things can be done using the Azure CLI. So again, this is just one simple script to run. Bam, you're done. Right? So when that's done, this is when I finally decide, you know what? I probably need to run some smoke tests to make sure everything's okay. So I run a set of user interface tests. These are just Selenium tests. So I hit my web app, make sure things are looking good. And remember, we had a mobile app as well. So I start running all of my mobile automated UI tests as well. And I do that by using app service. So are you guys familiar with app service? If you're not, app service is a tool from Microsoft that does all things apps, right? So it lets you build mobile apps really easily, lets you test them super easily. It gathers analytics really easily. It has a full set of REST APIs that lets you manipulate it and do everything easily, which means I can do everything in my pipelines really easily, right? So if I want to run a set of automated UI tests against my mobile app, it is literally one task, an app service test task. I give it the right information, and bam, it will go ahead and run all of my automated UI tests in the cloud for me against real physical mobile devices, right? And I think the last time I checked, there was like 2,000 different mobile devices that it will actually run against. And these are not virtual machines. These are real physical handsets, right? Really cool stuff. Some other things that I do, if you go ahead, jump into my UIT pipeline, this right here is where I can start adding some more tasks as well in terms of security, right? Because by the time I've hit here, what that means is I've already deployed everything that I need to in my resource group. So at this point, I don't have it here, but if I jump to the marketplace, I can start finding all sorts of security-related tasks. Security. And of course, it just goes on and on, right? One that I really like to use is the Security DevOps Kit. What that does is it will actually, you can set up policies for your resource group. And once I have the policy in place, by the time I can run this task, it will check my resource group and make sure that nothing is breaking those policies. And if it does, it will go ahead and stop my build right then and there. So this is great, because remember, I'm using infrastructure as code, right? So the developers can come in here, check in whatever infrastructure as code type stuff that they do. They can mess everything up, right? But as long as I have these security scans in place, we should be okay. So again, very powerful and very useful stuff. And finally, after running those two things, oh, here we go. Here's my security scan. I actually use an entire whole empty task or a whole other task to do that. And I go ahead and run all of my security scans there. And when all of that is done, now I'm finally done, right? So then I have a human being come and check it, make sure everything looks good. And if they approve it, we basically rinse and repeat, and the whole process will repeat itself and deploy out my production environment. If you notice my production environment, it does have an extra cluster because we have lots of redundancy and failovers in place. So like, what can you do with these pipelines? You can pretty much make it do whatever you need to, right? Really cool and really powerful stuff. By the time you're all done, it will go ahead, provision, and configure everything we need for rock, paper, scissors, lizard, Spock, lizard, one of those. That right there, as an DevOps person, makes me ridiculously happy. With one click, I'm able to go from complete disastery. Is it disastery? I guess it's a word now. I can go from complete disastery into disastery recovery with just one click of a button, right? So what have we shown you today? Some really cool stuff, right? We all know, without a doubt, Kubernetes, containers, that's like one of the most important things that's happened within our industry. Incredibly vital. The inner dev loop has always been rather painful for developers. But Fake Abel just showed us, wow, from my desktop, I'm able to debug what's going on in my clusters up in Azure, just like it was running on my desktop. As a developer, oh my God, that makes me so incredibly happy. Really? I don't need to worry about Kubernetes. I can just worry about my code. That's what I want to see, right? And then now we also have the power and flexibility of these pipelines where we can pretty much make it do whatever we need to including things like disaster recovery, data recovery, setting DNS, setting HTTPS, doing all the good stuff. Yeah. What can you do with these pipelines? Pretty much whatever your imagination can think of, especially with the cloud. It becomes almost trivial to script out and make it do whatever you need to do. So, call to action. Everybody out here, go to dev.azure.com, create a free subscription to Azure DevOps. Let's start building out amazing pipelines and automating absolutely everything. Jessica?
I'm coming up on stage too. We're wrapping up here. One more thing I wanted to call out that I was sitting here thinking about is obviously we're wearing wigs and we're talking about real world. That's funny and that's obviously fake. But one of the things Abel talked about in the very beginning is how he can do an hour-long talk about culture, about people. You just saw two people on stage whose backgrounds were primarily dev for 20 years. My background was ops for at least the past 15. In fact, I was a Windows MVP and I use Mac. I've been a Linux systems administrator, Windows MVP, IT Pro. I played with MDT Toolkit, SCCM, unattend XML files. Like, I'm as ops as you can get it. But one of the beautiful things when you do have that culture shift is you start to understand the other's world. You start to be able to share responsibility. I can do dev, he can do ops, and when you have that kind of teamwork, that kind of culture shift, that's the magic that you get to create. So I think the end goal, as much as the wigs and everything are funny, the end goal is the power of what can be done when it starts with that culture shift. Right? Then you can use the tools and everything else and have the pipelines and the practices, but they don't mean anything if you don't have the people working together. And as you can see, once we do work together, we have a lot of fun.
That we do.
So.
Yeah. So, go out there. Let's automate the world. Thank you all.
Thank you very much.